Hello everyone. In this video, we are going to see about how to sort an array in descending order using EMU8086 assembly language programming and in terms with the help of your hardware lab kit also. So first, we have seen our ascending order programming. So we have written a logic and we have tried to sort an array in ascending order. So the link for that program is already there in description. You can able to see that before coming to this video. So when you want to sort an array in descending order, what are the changes we have to make in the previous program so that it will be getting converted into descending order program. So first, while you are seeing your ascending order programming, so we want to declare how many comparisons we have to make. So if your array elements is going to be 5, so we are going to make comparisons for 4. So 4 comparisons are needed. So for that, we have declared two variables, which is going to be count variables. So we have declared as ch as 04 and cl as 04. So this is for outer loop and this is for inner loop, like that we have separated. So for the same, like the same we have to do here also, because number of swappings and other things are going to be same. So this is going to be inner loop. So if you want to see an array, so assume that it is in descending order, right? So 01, 02, 03, 04, and 05. Simple example, an array is being like this. So it is having 5 elements. So we want to take 4 comparisons, 1, 2, 3, and 4. So that is going to be your comparison count. So that is what your CH and CL is going to mean. So if your array is going to have 5 elements, you should declare it as 4. So in order to make the comparisons. So after that one, so if you want to take a look on it, so this is going to be in some memory location. Assume that it is going to be 2000, it is going to be at 2001, that is going to be at 2002, and after that this is going to be at 2003, and this is going to be at 2004. So in the same memory location, we have to sort it in descending order. So these are the elements or data inside that memory location, and this is your memory location, actually where it is being saved. So as we have seen in previous programs, so there is no possibility of comparison of elements directly. So we have to move to a register, then only we can able to compare it. So in order to compare it, we have to move to any register. So declare it as SI, source index, as 2000. So after that one, if you are going to keep on incrementing your SI, it should move to the next memory location so that it can able to check with the next elements. So in this case, we can able to take 2 different variables. So assume that it is going to be AL, so which is going to take the value of SI. So if I want to convert the same thing with commands, so it is going to take move command. So after that one, BL should be taking the value of SI plus 1. So since it is going to be 8-bit, so if it is going to be SI plus 1, it is going to shift to the next memory location of 2001. So after that one, here also we have to compare those 2 elements. So again, compare statement is needed while having your AL and BL. So we know that the compare statement is going to compare it within your AL and BL. So AL is going to be greater than BL. I'm having 3 cases. AL should be equal to BL, or AL should be less than BL. So I'm having 3 different cases. So depending upon that, my flags will be set. So if it is going to be your carry flag, so your carry flag will be 0 here if the comparison is going to be same as this one. So here also your carry flag will be 0. And here your carry flag will be 1. So if AL is lesser. So in this case, so if I am going to compare 0, 1 and 0, 2, in this case, which one is going to be the thing which is going to happen? So AL is going to get the value of 0, 1 and it is going to get the value of 0, 2. So it will have its carry. So If it is going to have its carry, which means it is not in your descending order, or it is not in the way which you want to sort. So it has to come to the next swapping stage, which means this needs swapping. So I have to swap these two elements. So AL is lesser. So which means like your carry flag is going to be happening there. So here if you want to take in terms of your carry flag, so if carry flag sets, so if no carry, if that is the case, so which means swapping should not happen, so that I have to move to some memory location which is not there specified here. So assume that it can be anyone which is going to be having miss. Assume that I am giving a declaring a variable miss. So if this carry occurs, which means it should not jump, so this was to swap its values. For swapping it, so I need a temporary register. In your C programming, as like we are having a, if you want to swap A and B, so what you will do, A is equal to T, and after that we will be saying that moving the value of A is equal to T, right? So your value of A will be moved to this temporary value of this, sorry, going to be T and this going to be A. So in this case, A will be moved to the temporary register. So after that, the value of A is going to get the value of B. So like this, if I want to swap it, swap those two elements. So in between, I need a temporary variable so that I can able to save the value temporarily at some location. So like this, I will be having a temporary variable. Like the same, I need a temporary variable here. Here I don't have any variables, so I have to make use of my registers. So I will take my DL register. So in the DL register, I will save my SI plus 1. So after that one, I am ready for exchanging. So the same command, XCHG, which is going to be taking place. And after that, it should be SI, DL. DL value is moved to this SI values. And after that, I can able to move the value of SI plus 1 to DL. So like this, I can able to move the values, and I can able to get the values in the different memory locations also. So here in this cases, so I need to exchange. So I have done temporary variable DL. So DL is going to be getting the value of SI. So after that one, SI plus 1 can able to move to the next element variables. Like this, I can able to swap it with the help of my temporary variables, which we can able to see it in your program. So after that one, we have to increment our SI, and after a while you're incrementing your SI, so it is going to move to the next memory element. So this actually this swap happened here, which means like it is going to be 02, and after that it's going to be 01, after that is going to be 03, after that is going to be 04, after that is going to be 05. So now the comparison should happen between 01 and 03. So SI has been updated. So SI is equal to SI plus 1, so that it is going to be getting the new location of 2001. So this 2001 is going to be the next values, and after that has to. So in the same way, I have to decrement my CL register, which means I have to decrease the count so that it is going to compare between all those values. So in the next iteration, it should be 02, 03, 01, 04, and 05. And again, it has to compare it. And after that, again, it has to be swapped. So next element, it is going to be 03, 02, 03, 04, and 01 and 05. After that, this two has to be compared so that it will be 02, 03, 04, 05, and 01. So till this, it is your iteration 1. So your count value has to be decremented, CL value, which is going to be decremented here. So here your CL is going to be decremented so that it can able to have the value of 3, 2, 1, and 0. When it is identified 0, it will jump out of the loop and will come back to the initial state itself. So like this, I have to decrement my CL. So here I have to have a jump statement. So this jump statement should be jumping to the element of SI. So which means like I have to move to this location itself. So after each iteration, it should move to that value. And after this point, I have to decrement my CH. And after that, again, I have to jump no carry. So for this jump no carry, it should go to the memory location of CL is equal to 04, which means again it has to swap it 4 different times. Then only it can able to have swapping every 4 times. So the iteration inner loop should be having 4 times, and after that outer loop will be having 4 times swapping. So in the same case, it has to iterate it again and again so that it will reach an descending order fashion. So whenever swap is needed, it has to exchange. Whenever the condition jump no carry occurs, it has to jump out of the loop, and it should not swap its swap. So like this, I have to make a logic so that it is going to bring to descending order. So to understand this one, I can able to go to my EMU8086 to see the logic how it works. So only change which you are going to make here from ascending to descending is only this one. So there it will be jump carry, here it will be jump no carry. So in order to make that, so I have made CH is equal to 0, 4, and after that CL is equal to 0, 4. So loop 1 will be jumping here. After that one, same logic, SI is equal to 2000, AL comma SI, it is going to take its next position, comparison, and after that jump loop 3, so that whenever there is no carry, it has to jump, which means like it should not swap. Whenever there is a carry, it should swap. So after that one, it has to increment its SI. So incrementing SI will be loop 3, so that it is going to get its loop, and after that it is going to swap itself. So it has to jump here to here. And after that one, decrementing CL for inner loop and decrementing CH for outer loop. So again, it has to jump to the loop 1. So this operation is going to be continuously happening so that it can able to take its new value. So in this fashion, if I want to move further, I can able to simply run this one. Yeah. So I can able to check with my memory locations, AUX memory. So I can able to take this one. I can able to check with my flag status also here, and I can able to check the flag status, and I can able to put those elements here. So your data segment register is going to start at 0700. So it is at 0700. That one, your memory location is going to be 2000, so that I'm going to give the value of 2000 update. So I have to make it in descending order, right? So the value should be somewhat in terms of your ascending order, so that it is going to be 02, after it is going to be 03, after that it is going to be 04, after that is going to be 05. 5 elements. So I have declared number of swaps or number of comparisons to happen is going to be 04. If it is going to be 6 elements, it is going to be 05. So correspondingly, you have to make your CH values, then only it will run. So I can able to execute one by one so that it is going to check for its output. So CH is going to be 04. I got 04. Before that, it is having some garbage values. You can able to see that. So after that one, this CL is going to be getting 04 value. And after that, SI value is getting the value of 2000. Yes. And after that one, your BL should be getting the value of SI plus 1. So SI plus 1, I can able to have it here, and I can able to take those things. And after that one, I can able to check it. So comparison of AL and BL. So it is going to happen. So AL is going to be getting compared with BL. So here it is going to check your carry flag will set, so that it will have its swapping operation. Else it is going to jump out of that one. So now it has to swap the values between 01 and 02. So whenever it is going to change its values, I can able to see here. So here in terms of your exchange, so you can able to see the values which is going to be changed here. So 01 and 02 is getting changed here in terms of your memory elements. And after that one, I can able to execute it, run, and after that I can able to increment SI, after that decrement CL. So loop, all those things are going to be happening the same fashion, so that 01, 03 getting replaced at this iteration. And after that one, 04 and 01 is getting iterated, and it is going to get its swapping. And after that one, 01 and 05 is getting replaced, because 05 is going to take position. So like the same, so now one of your inner loop is getting completed. So it has to decrement its CH. And after decrementing your CH, it is going to be taking it 0, 3, and after that CL should be 0, 4 because it has to take comparison against 4 times. So that's why we are going to jump for CL is equal to 0, 4 here. So after coming out of this one, CL is decremented, and after that one loop. So where you are going to set your CL again to 0, 4, right? 0, 4, and count value is decremented to 0, 3. Again, this iteration is going to happen between 2 and 3, and after the 3 and 4, after that 4 and 5, like that is going to happen. So I can able to check for it. So 0, 2 and 0, 3 it is going to compare itself. So 0, 3 and 0, 2 is getting swapped between each other. And after that one 0, 2 and 0, 4. So 0, 2 and 0, 4 is getting swapped with each other. And after that 0, 4, 0, 2 and 0, 5. Again, it has to swap it. So it has to reach its position, right? So it has reached its position. After that, when it is going to compare between 0 and 0, 2, swapping operation should not happen. So at that time, your carry flag has to be there. So whenever there is no carry flag which is going to be set, so it is going to jump out of that loop. That is what we want. So when I am going to compare this one, so here decrementing CL, after that, so here it is going to have its comparison operation. So comparison operation between 0, 2 and 0, 1 should happen. So 0, 2, 0, 1, it should not swap. So that's what our main iteration, which is going to be our logic. So yes, it jumped. So there is no swapping operation which is going to happen here. So 0, 1 and 0, 2 will not be swapped. It will jump here and it will increment CSI. So like the same, the operation will be performed till all the things are getting swapped with each other. I can run it. So whenever there is a carry flag, it is going to swap it. Whenever there is no carry flag, it is not going to swap its elements. So like this, I can able to do the operations one by one. So this is the logic for your descending order. So this is with EMU8086. If you want to move with hardware, only changes which are going to make here is going to be this loop has to be replaced with memory values or memory locations. So only those things I'm going to make a change here. So I can able to see how it works here. So this is the logic which we have derived. This is the thing which you are able to see in terms of our program. So here you can able to see I have started with CH is equal to 0, 4. That is fine. Yeah. So CH is equal to 0, 4, CL is equal to 0, 4. And after that one, this is going to starting location is 2000. And after that memory is going to be getting inside. AL, SI plus 1 comparison. So here I don't know this value which I have to get it here. So actually this value is here, right? So till that time, since I don't know the memory location of that instruction, I'm giving any dummy values. So assume any of your dummy values, I can able to give here, and I can able to complete my program. And after completing my program, I know whenever I am reaching this instruction, I know this memory address, and I can able to note down this memory address. And after that one, I can able to replace this memory address here. So this is called dummy replacement. So in order to do that, first, while you are seeing your previous program, we have typed with giving assembler A, and after that you will be giving the starting address 1000. And after that you can able to start typing it, right? So after completing all, note down this address and keep it ready. And after that one, if you have forgotten that line also, you can able to check with you, and you can able to go to that memory starting address, and you can able to check one by one. And after that one, so this is going to be 101B, right? So here in terms of your 101B, so here it should be in the instruction 1011. So I want to edit only that instruction, which is going to be here. This instruction I have to edit it, right? So this memory location. So here what I will do, I will enter the value A, and after that I will enter the value of 1011. So it is going to show a new line. There I can able to enter jump no carry 101B instead of the dummy variable 2050, anything. So I can able to replace it, and I can able to make that thing to happen. So the logic is going to be same here, exchanging. If it needs exchange, it should exchange, else it should not exchange. So decrement CL. So this jump no carry is going to be your inner loop. So inner loop has to jump here. And after this one, this is going to be your outer loop. Outer loop has to jump here. That is the logic we have designed, right? So like the same, we will be identifying its logic, and after that we are going to make its corrections. So while you are seeing your input, I am trying to give some random values in this memory location 04, 05, 02, 01, and 03 and 01. So after executing this operation, it should be having the values of 05, 04, 03, 02, and 01. So we can able to enter inside our hardware programming. So this is our hardware programming. So already I have typed the program, so I can able to start with command U itself. So U, after the starting address of the program, which is going to be 1000. Enter, enter. Yeah, CH is equal to 004, which means move CH comma 04, CL comma 04. SI starting address, A which is going to be replaced, and after that BL SI plus 1. Compare AL comma BL, no borrow, right? Which means jump no carry and borrow is going to be same. So move DL comma SI plus 1, exchange SI DL, and after that exchange DL comma SI plus 1. So here decrementing CL, after that jump no 0, 100A, decrement CH, jump no 0, 1003, halt. Same program, I have typed, reset. So SB, space 2000. So I am able to enter the values one by one. So I have given the values 01. After that I can 02. After that 03. After that 04. After that 05. So in this manner it should be operating. So I have to give go command, and after that starting address of the program, executing, reset, and SB, the memory location of the data which is getting saved. After that one, it is going to be 04, 02, 03, 02, 01. So it is running order. I can to see all those things one by one. So this is how I can able to use the same values, same location, and I can able to sort the array in descending order. So only change which you are going to make here is with jump carry and jump no carry with your ascending and descending. Thank you for your patient listening.